Over here, and this is the 2004 AIME 1 problem 13. Here's a view of this problem. The polynomial p of x is equal to 1 plus x squared all the way until x to the 17, that thing squared minus x to the 17, has 34 complex roots of this form, right? Our general polar form. For k equals 1, 2, 3 all the way to 34. With 0 less than a1, less than or equal to a2, less than or equal to a3, all the way until less than or equal to 34, which is less than 1, and r sub k greater than 0. And then we want to find the sum of a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5. So first, of course, we have to find the roots. And this polynomial may look scary, but there's a couple of good things you can notice about this. Squared minus x to the 17th. The first being that this is a geometric progression. So if you know anything about the roots of unity or geometric progression, we know this is immediately factorable as x to the 18th minus 1 over x minus 1. And then we need to square this, minus x to the 17th. And since we have no other better thing to do, let's just square both the terms. We get x to the 36th minus 2x to the 18th plus 1 over x squared minus 2x plus 1 and then minus x to the 17th. Again, nothing clever we can do, so let's just multiply top and bottom by the denominator, get a common denominator. And then doing this fraction subtraction, we get, okay, x to the 36th minus 2 times x to the 18th plus 1, and this is negative x to the 19th, and then this becomes negative 2x to the 18th, but then that's a negative, so that becomes a plus 2x to the 18th, and then now we have negative x to the 17th. We realize that these cancel, so we have x to the 36th minus x to the 19th minus x to the 17th plus 1 over x squared minus 2x plus 1. And then now we realize that we can factor. So x to the 19th times x to the 17th minus 1. And then boom, negative 1 times x to the 17th minus 1. And now this is good, because now we can factor out the x to the 17th minus 1 times x to the 19th minus 1 over x squared minus 2x plus 1. And then the denominator is x minus 1 whole squared, so we can actually rewrite this as x to the 17th minus 1 over x minus 1 times x to the 19th minus 1 over x minus 1. Good. Now we know that the roots of this thing, when this is 0, the roots are the 17th roots of unity beside 1, and the roots of this are the 19th roots of unity beside 1. So since we double count the 1, we get 34 complex roots, as should be. Great. So what are the roots of this 19th roots of unity besides 1? That'll be, let me just write x to 19 minus 1. That'll be e to the 2 pi I by 19. And then we're actually asked, to collapse this into polar form and then find the a sub k's, respective a sub k's. And then we just realized that the a sub k for this one is 1 over 19. So I'll just add 1 over 19. And then e to the 4 pi I over 19. The respective a sub k for this is 2 over 19. And since we want the phi smallest, we don't actually have to list a whole lot of terms. Maybe you can list maybe 2 more. Because we also have the 17ths to consider. This is, of course, 3 over 19, 4 over 19, and then how about x to the 17th minus 1? That gives us e to the 2 pi I by 17, and then I'll stop maybe after 3, so e to the 4 pi I by 17, and then e to the 6 pi I by 17. This is 1 over 17, 2 over 17, 3 over 17th. So we want to find the smallest of the a sub i's, or I should say, yeah, a sub I, sure. And so we have 1 over 19. 1 over 19 is obviously the smallest. And then 1 over 17 versus 2 over 19. If we multiply both top and bottom by 19 over 17, we get 19 over 17 over 19. And then 19 over 17 is still in the ones. So 1 over 17 is the second smallest, followed by the 2 over 19. Okay, and then now we get to the 2 over 17 and 3 over 19. Now we just note that 19 over 17, 38. We just note that these two will also be the corresponding smallest ones. I'm not gonna figure out which one's smaller, although that'll be pretty easy, but we note that they both must be a sub 4 and a sub 5 in some order. Therefore, this is our desired sum. Combining like terms, that gives us 6 over 19 plus 5 over 17. That gives us 17 times 6, which is 102 plus 85. Let me just 4 over 17. 4 over 17, let me just make sure that looks good. Oh, what am I doing? 3 over 17. 3 over 17. Okay, that becomes 102 plus 57, 159 over 19 times 17. That's 19 times 20, which is 380 minus 57. That's 323. And then these are relatively prime. We can note that since the prime factorization of this is simply 19 times 17 and none of those divide 159. So this is in the format they want. Thus the answer is 482 when we add the two things, and we're done.